The objective for this experiment, which is Hooke's law, is to verify the accuracy of Hooke's law.
Hooke's law is a principle in physics that states the force required to extend or compress a spring at a certain distance is directly proportional to that distance. This relationship may be written as F equals to negative kx, where k is a constant proportionality. The minus sign indicates that the force is in the opposite direction to the displacement and is always towards the equilibrium position. When an object is hanged to a spring and were led to equilibrium, the total forces acting on the spring is equals to 0. Hence, sum of Fy, which is the forces on the y-axis, is equals to 0.
The apparatus are helical steel spring with supporting stand and scale, set of slotted weights with hanger, and weight balance.
The mass of the hanger was measured and recorded. The weight of the hanger was calculated and recorded as W in the table. The scale was adjusted so that the pointer on the hanger was near the upper end of the scale when the scale was being unloaded. The position was recorded as x0. The hanger was loaded by a 20-gram mass. The scale reading was recorded as x1. The load was increased by a suitable increment to obtain 8 data points before the lower end of the scale was reached. All data, W and X1, were recorded. The process was reversed by unloading each load in step 3. The new scale reading, X1, was recorded for each load. The extension of the spring, delta X, was calculated. The extension force acted on the spring, F, was determined for each total loads. From the graph, it is seen that the extension force F against the extension of the spring X is a straight line, meaning that F is directly proportional to X. This proves Hooke's law.
Okay, for the conclusion for this experiment, Hooke's law, that the elongation of the spring changes as the forces applied on the spring changes. As the force applied on the spring increases, the elongation of the spring also increases. Nonetheless, when the spring constant is increases, the force is required to compress or extend the spring will increases. This shows that spring constant is inversely proportional to the elongation of spring. Hooke's law stated that the extension of or compression of a spring is directly proportional to the applied force by using this formula, which is F equals to kx. Additionally, we use the formula for the weight. W equals to mg, as g is equals to 9.80, and to convert mass into weight in order to calculate the force applied. Parallax error and air resistance could be deterred to derive a more accurate results. As stated above, the position of the eyes must be perpendicular to the reading scale of the ruler and the windshields could be used.